Hi, hello. Today we shall be developing. Today we shall be developing heteroscedasticity in the in the in the regression model, right? So today we shall be developing heteroscedasticity in the model, and later on we shall remove this heteroscedasticity from the regression model. So that is our job today. Today first we shall develop the heteroscedasticity in the model, and later on we shall remove this from the regression model. And normally heteroscedasticity is not desirable in a model. Heteroscedasticity is not desirable in a estimated regression model. Okay, so and here we have some variable today. So variables are here. I can show you. So these are the variable that we have, right? So here you can see we have all this. We have three variable. I'm just going down. I may make it adjust. You just wait 1 minute. Just 1 minute. Just I make it adjust slightly. Okay. Okay. Make it small. Okay. So here we have three variable. One is y, x1, x2. So these are my variables, right? So these are my variables, y, x1, x2, and so on. Okay, and here so you can see all variable now. This is y, this is x1, this is x2, and y is our dependent variable, and x1 and x2 are independent variable for our model. And you can see all the data now. So here you can see all the data. So sorry, I've done a mistake. You can see all the data here. So I'm going down. So our sample size is 50. That is our sample size from 1 to 50. Okay, now we shall be developing the regression model, and then we shall be developing the heteroscedasticity. Okay, so first I run analyze, then I choose this one, linear model, linear regression model, that I choose. Later I click on it, and here you can see, okay, I'm making it fixed. I'm doing it again. Y is the so here is the dependent variable, and this one is the independent variable. Okay, so first I take y here as a dependent variable, then I take x1 and x2 as a independent variable. So this is my model. Y is dependent, x1 and x2 are independent variable. Now we can run this model. Okay, but here we check the statistics first. What is it? Statistics. I click on it. So here I choose estimate. That means all the coefficient will be estimated. Then I choose model fit. So only these two I choose for the time being, meaning that for the time being I select only these two. Then I click OK, continue. I click on the continue. Okay, then I go to plot. So I'm sorry. So this is the plot, and these are all the residuals, right? All are residual of the estimated model. And here is the y, and here is the x. So what is y? Y means y-axis. Y means y-axis. And what is x? Here x means x-axis. Okay, here in y, I put z receipt. I put z receipt, and in the x-axis I put z pred. Okay. Now my question is that what is called z receipt and what is called z pred? Okay. So first I talk about this one, z receipt, and then I talk about z pred. Okay. So here z receipt means standardized regression, standardized residual, standardized residual of the model, right? That is z receipt, meaning that the whole thing has come from z distribution. You can see z, right? That means the whole thing actually come from z distribution, and that is also standardized residual of the model that we are developing now. Then we have one more, z pred. What is called z pred? Also the standardized predicted dependent variable, right? So meaning that we can call it predicted dependent variable, and here our dependent variable is what? Y. Y is our dependent variable for this model. Y is our dependent variable for this model. Okay. So we have two things. One is z receipt and z pred. And now we shall be plotting this z receipt and z pred, and that is our plan. We shall be plotting z receipt and z pred, and the whole thing is here. You can see from here we are plotting. You can see plot. Here we are plotting, and here in the y-axis will be z receipt, and in the x-axis will be z pred. Okay, now we have set it already, and we are doing all this thing to check whether our residual has heteroscedasticity or not. That means whether z receipt has heteroscedasticity or not. And if there is a heteroscedasticity in the residual, then we shall remove it from the model. That means we shall remove the heteroscedasticity from the model. Okay, now we plot it. We plot this thing. So I go to continue. Okay, then I go to OK. This is OK. So the model is estimated. This is our model, you can see, right? This is our model, right? This is our model. This is the result. And here I can make it slightly big. As a result, the result will be more visible to you. Okay, suppose here you see y is the dependent variable and x2, x1 are independent variable. Okay, now I talk about model summary. Okay, what I can do, I can make it big for you so that the whole thing will be more visible. I make it select, then I choose the cell properties and I choose here 16. As a result, the whole thing will become big. You can see from here. So here you can see the R squared is very high. The R squared is almost 88.2%. The R squared value is 88.2%, meaning that our model is nicely fitted, or the variables are nicely fitted, because R squared is very high, 88.2% out of 100%. Okay, so we are happy about it. Then we check about ANOVA. So what I do as before, I make it big, I cell properties, I make it 16. Okay, so it has become so big now. Now this F statistics and the corresponding significant value is significant. That means the significant value is very small, less than 5%, meaning that F statistics is significant, meaning that our two independent variable such as x1 and x2 are significant to explain our dependent variable, which is y. Okay, so I'm telling again, our significant level or probability value or p value is less than 5%, meaning that F statistics is significant, meaning that our two independent variables such as x2 and x1 are significant jointly to explain our dependent variable, which is y. So we are happy about this model. Why? Because R squared is very high, which is desirable, and the F statistics is also significant. So we are happy about the model. Finally, we check the coefficient, right? How many coefficients are significant individually? I make it big so that the whole thing will be more visible. Cell properties, then I choose 16, right? I make it big, so it has become big now. You can see from here. Okay, here you can see we have two independent variable, and out of two you can see the first one, x1, the significant variable, significant value is very small, less than 5%, meaning that x1 is a significant variable to explain our dependent variable, which is y. Okay, then I talk about x2, whether x2 is significant or not. So here is the significant value or probability value or p-value. Okay, here the probability value is 44%, which is more than 5%, meaning that x2 is not a significant variable to influence our dependent variable, which is y. Okay, so here what is happening? Out of two variables, one is significant, meaning that 50% of the independent variables are significant. So we are happy about this coefficient result. Actually, what is the guideline? The guideline is if most of the variables are significant, then the model is acceptable. And here, out of two variables, at least one has been significant, meaning that the result is good. We can accept this model. Okay, so here what is happening? So here R square is very high. We are happy about it. Then F statistics is significant. So we are happy about it. And the coefficient out of two, at least one is significant. So we are happy about it. And normally what is the guideline? The guideline is if the significant value is less than 5% or if the probability value, so both are same thing. If the probability value is less than 5%, then that particular matter is significant. But if the significant value or probability value or p-value is more than 5%, then that particular variable or statistics is not significant. So that is always a guideline. Okay, now we shall be checking today whether the residual of this model, right? Residual of this model has heteroscedasticity or not. That we want to check. And if there is a heteroscedasticity, then we cannot accept the model. But then we have to remove this. We have to remove the heteroscedasticity from the model, and only then we can accept the model. Okay, that we shall be doing now. Okay, okay, that we can do now. Okay, thank you very much. Then in the next slide I shall explain other thing also.